Good morning, friends. This is Aditya Agarwal talking to you, explaining about annealing and normalizing. So let's start. Annealing. First, annealing. It is a process of heating the metal to a suitable temperature and slow cooling inside the furnace. So it's basically a process where we heat the metal to a suitable temperature and cooling the metal itself inside the furnace. So we let it sit inside for quite a time. As a result of slow cooling, the metal occurs an equilibrium structure, which causes the following: to relieve the internal stresses, reduce hardness and improve ductility, to refine the grain size, to produce a definite uniform ductile coarse grain structure. So you can see the grain structures of annealed and normalized structures. So applications of annealing: casting, forging and press works. Types of annealing: full annealing, which is nothing but hypoeutectoid steels. These steels contain less than 0.7% of carbon, are heated to 723 to 910 degrees centigrade. This is done to obtain austenite structure and the temperature is maintained for a period of time. Cooling is done inside the furnace by decreasing the temperature 10 to 30 degrees centigrade per hour. This means cooling is done itself inside the furnace at a decreasing rate of 10 to 30 degrees centigrade per hour. Then the specimen is removed from the furnace and then air cooled to the room temperature. Structure of pearlite is obtained, which has uniform medium coarse grain size, which is soft and ductile in nature. The next type of annealing is hypereutectoid steels, which is more than 0.7% of carbon. So this is heated up to 723 to 1138 degrees centigrade because it has more percentage of carbon than hypoeutectoid. Then again it is cooled inside the furnace at a decreasing rate of 10 to 30 degrees per centigrade, then air cooled to the room temperature. The structure is obtained will be coarse pearlite in nature. Objectives of full annealing: soften the metal, refining crystalline structure, reduce hardness, relieve internal stresses, improve machinability, and improve ductility. So here ductility is nothing but a property of metal to be drawn in the wires. Okay, and the next type of annealing is process annealing, which is also known as low carbon steels. In this process, it is a heat treatment process used to soften and increase the ductility. The metal is heated between 650 to 750 degrees centigrade, held for a period of time to achieve softening. Later, they are cooled. This process leads to recrystallization, leads to improved ductility, softness, free from internal stresses. The above heat treatment results in hardness reduction and increase in percentage of elongation. So as the temperature increases inside the furnace, the metal heats up and the hardness obviously reduces, and the increase in the percentage of elongation also increases because the microstructure of because the atoms present in the metal gets softens and elongates. So applications of low carbon steels are sheets and wire manufacturing. As I told you, it can be drawn into wires, so ductility is the common application. So another type of annealing is stress relief annealing, which is also known as alloy steels, employed to eliminate the internal residual stresses included by previously strained hardened metal. In this, the process uses cold working process, and the applications are casting, machining, cold working, welding, forging, and rolling. So the important point come here. Internal residual stresses are caused due to plastic deformation process, non-uniform cooling of a metal, heating and cooling of alloys made into two different metals having different densities. So these are the causes of internal residual stresses. Now we'll read about effects of internal residual stresses. If the stresses are not removed, distortion or warpage of material occurs. Operation. How to do this? The alloy steels are heated to 650 to 750 degrees centigrade, held for a period of time and cooled out slowly. This type of treatment is called as recovery, which is the phenomenon that removes internal residual stresses with a little change of mechanical properties and no drastic change in microstructure. And the another type of annealing is periodized annealing, which is also called as high carbon steels or tool steels. These steels are too hard and difficult to machine. These steels are too hard because they have more content in carbon. The heat treatment is done between 750 to 800 degrees centigrade, and holding the specimen at the same temperature for several hours, like 2 to 5 hours, and cooling it inside the furnace. As this is our annealing process, so we cool it inside the furnace. This process of spheroidal formation, which is cementite structure, which is hard in nature with soft grains. Objectives of spheroidizing: to soften the hardened material, to improve ductility, machinability, formability, to maintain medium hardness, strength, and wear resistance. Now we'll go to normalising, which is another type of heat treatment process to steels. So this is done on low, medium carbon and alloy steels. It is the process of heating the metal and cooling the metal in the air. Whereas annealing cooling is done itself inside the furnace. Now normalizing is a heat process where cooling of the metal is done in the air, in the open air. Objectives: to refine the grain size, increase the strength of steel, non-uniform structure when compared to annealing, relieve internal stress, improve machinability and ductility. Operation: how normalizing is done. The steel is heated between 750 to 950 degrees centigrade. It is held at this temperature for a short time, whereas annealing was held for a period of time like 2 to 5 hours or 3 hours. In normalizing, it is 15 to 30 minutes, allowed in the cool and air. Due to faster rate of cooling, normalized steel possesses fine grain structure than annealing process. The differences between annealing and normalizing: grain size is coarse when compared to normalizing process because of slow cooling process. Fine grain structure is obtained as cooling process is faster than annealing, as said before. Annealing is more expensive process because the cost of furnace and temperature sensors. Normalizing doesn't need much apparatus, so it is less expensive process. And annealing is a more time consuming process, and normalizing is less time consuming process. And annealing is done less than 900 degrees centigrade, and normalizing is done at more than 900 degrees centigrade. Annealing is to relieve internal stresses and to soften the metal and improve the ductility. And normalizing to improve the mechanical properties of metal like strength and toughness. Annealing, grain size distribution is more and uniform, and normalizing, grain size distribution is less and non-uniform. Annealing, less hardness is obtained; normalizing, more hardness is obtained. Annealing, less hardness is obtained because heating is done less than 900 degrees centigrade and cooled at very slow rate, like 10 to 30 degrees centigrade per hour. So due to that, distribution of grain size is uniform and less hardness is obtained. And normalizing, more hardness is obtained due to we heated more than 900 degrees centigrade, due to which ductility and various other factors come into picture. And cooling rate is faster than annealing because we leave it in the open air, so it decreases the heat very fastly. So hardness is obtained due to grain size distribution is less and non-uniform. And So this was the thing about annealing and normalizing. So hope you understand what I explained. So thank you so much. Again, signing off as Aditya Agarwal.